Hey folks, Serdar here for InfoWorld. In this episode of Smart Python, I'm going to demonstrate two powerful Python built-ins, all and any. So here's a common scenario. You have a collection of items, like a list, and you want to determine if all of the items, or any one of them, satisfy some condition. That's what all and any let you do, and they let you do it in an efficient and compact way. All and any take an iterable of some kind, again, like a list, and go through each element in the iterable to see if they evaluate to true. With all, the test is to see if all items evaluate to true. With any, the test is to see if any one item evaluates to true. What's convenient about how both of these operations work is that they terminate as early as possible. If you use all, the moment it finds one of the items in the iterable evaluates to false, all quits processing and returns a result. Likewise, if you use any, it quits processing as soon as it finds a true value. That way, you can structure your tests to terminate as quickly as possible depending on the conditions. In this example, I'm using any with a list of integers. If an integer is 0, it evaluates to false. Any other integer, including a negative number, evaluates to true. So the first test will yield true as soon as we hit 1. And here, with all, I'm feeding it, again, a list of integers, but these all evaluate to true, so the results of this all test will be true as well. The next two tests I have here both yield false, and here's why. The first one has not only 0 in it, but none, and none also evaluates to false, so none of these will evaluate out to true. The second one, we have -1 as a value, and negative numbers evaluate to true, even if everything else in this list also evaluates to false. So the whole test will evaluate out to false. Now, what if we want to perform more elaborate evaluations on these lists? Well, we can do that by simply wrapping our iterable in a generator and yielding a Boolean value, a true or false, for each item by way of an expression. For instance, for this first one, we test to see if each element in X is greater than 1, and that will yield either true or false. So for number 2, we test if all elements are greater than 0, and that will yield true in this case. For 3, we test if any element is 1, which will yield false in this case. And for 4, we test if all elements are none, which again will yield false in this case. So the tests here will yield the same results as the last set, true, true, false, false. Now, using a generator like this does add a bit of overhead, because we have to perform an additional test on each element. But the overhead is not significant for most use cases. All and any are internal to the interpreter. They run in C, so they're highly efficient. And one other important behavior to note is how all and any deal with empty collections. All will return true if an iterable is empty, and any returns false if an iterable is empty. Now, this might seem a little counterintuitive at first, but here's one way to think about it. All returns true by default, in other words, unless proven otherwise, and any returns false by default. So an empty iterable for either of them will just cause them to return whatever their default value is. So to sum up, all and any take an iterable of some kind and evaluate if all of the items in it evaluate to true, or if any of the items in it evaluate to true, respectively. Each test quits as quickly as it can, and for empty iterables, all will return true, and any will return false. That's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the Tech Talk channel on YouTube, and for more Smart Python and more Dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.